Hello everyone! Today we're going to be solving the question valid anagram. The question prompt gives us two strings s and t, and we need to return true if t is an anagram of s and false otherwise. The question also defines an anagram as a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. From the given definition, it's easy to understand that in order for this to be possible, the two strings need to have the exact same characters with the same corresponding frequencies. Let's take a look at some examples. In the first example given, we see that S contains 3 A's, 1 N, 1 G, 1 R, and 1 M. And we can also see that T also contains 3 A's, 1 G, 1 R, 1 N, and 1 M. And it turns out we can rearrange T to match S and vice versa, so we can output true. In the second example, we can see that S has R, A, and T has C, A, and R. Since we cannot rearrange T to match S, we need to return false. Given the definition of an anagram, one approach to this problem would be to sort S and T. This ensures that the same characters appear in exactly the same order in both strings if they are anagrams. Then we can compare these two strings and return true if they are the same and false otherwise. If we take a look at the first example, sorting S would give us the following string. And sorting T would give us the following string. As you can see, the sorted versions of these two strings are exactly the same. Then it must be the case that these two strings are anagrams, so we need to return true in this case. Looking at the second example, sorting S gives us the following string, and sorting T would give us the following string. As you can see, the sorted versions of S and T are not the same, so we need to return false. This approach has a time complexity of O of S log S plus T log T, where S and T are the length of the strings, and a space complexity of O of 1 if we do not count the space used by the sorting algorithms. A better approach would be to somehow keep track of the characters of these two strings and their corresponding frequencies and compare them. This can be done with the help of two hash maps. Each hash map is going to store the characters as key and their frequencies as value. If the characters or their corresponding frequencies do not match, we can be sure that these two strings are not anagrams. For the first example, the first hash map is going to look something like this, and for the second string, it's going to look something like this. As you can see, the letters and their corresponding frequencies are the same for these two strings. By comparing them and see that they're equal, we can return true. For the second example, the first hash map looks something like this, and the second hash map looks something like this. Even though the values are the same, the keys are not. So we need to return false because we can conclude that these two words are not anagrams. This approach has a time complexity of O of S plus T because constructing the character to frequency hash map of each string and comparing them are linear time operations. The space complexity is also O of S plus T. Let's code the solution. For the coding portion, we're actually going to take a slightly different approach. Instead of using two hash maps, we're going to be using one to store the characters and frequencies of S and iterate over T to decrement the counts within the same hash map. If at the end all counts are 0 and we do not encounter a different letter while iterating over T, we can return true. I'm going to be first comparing the lengths of these two strings because if they're not equal, they cannot be anagrams. So we need to return false. Then I'm going to be initializing the hash map and name it char frex. This is going to hold the char frequencies of S. So we need to iterate over S. Then I'm going to be incrementing the count of the corresponding character. This method in Python allows us to get a default value of 0 if char does not exist in char frex yet. Then I'm going to be iterating over T and try to decrement the count of char from char frex. But before that, I need to check if this char is contained within char frex, because if not, we need to return false. This is because of the fact that if these two words do not have the same letters, they are not anagrams. Then we need to iterate over t one more time. This time we need to check if the current frequency at the current character is equal to 0 or not. If it's not equal to 0, we need to return false. And finally, if we do not return false in any of the above cases, we can now return true. And this solution is guaranteed to work because, as I aforementioned, anagrams should have the same characters with the same frequencies. We're firstly building up the character to frequency hash map with the letters of S and decrementing the frequencies while iterating over T. If these two strings have the same frequencies for each character, then subtracting them should give us 0. This is why this solution is supposed to work. And now let's hit submit. I've actually made a small typo here, and now we can submit again. And as you can see, this solution works and is pretty efficient. I hope you found this helpful. If you did so, please leave a like below and subscribe to the channel. It supports the channel a lot, and I'll see you in the next one.